Good morning, guys, or afternoon or evening, whenever it is you're watching this. We are going to do basically the last section of section 8 already. We've already done a z-test, which means that we know that the standard deviation that was given to us is from the population. We've already done the t-test, which means that we have gotten a sample standard deviation. And now all we have left is proportions. And these proportions are actually very, very simple. Okay. There's a couple of things that you need to understand, and I'm going to write down those formulas for you. In order to find the mean of a proportion, it's really actually very simple. It's mu is equal to n times p. That's it. And reminder of standard deviation, it is the square root of n times p times q. So again, we're going back to proportions, we're going back to the easy stuff. And reminder of our z-score, it is p hat minus p over the square root of pq over n. Remember that p hat is x over n. P is your proportion, the population proportion, and n is your sample size. Okay, and again, observed p hat, what you saw, minus the expected over the standard error, which is the square root of p q over n. All right, so we've got 2 example problems for today, and then that'll be it for the video. So I'm going to pause and I'm going to write the first example problem down. Okay, so our first of 2 example problems. I claim that females do better in math than the general population. The A rate for the general population is 52%. 16 out of a random sample of 27 females had an A. Can we say the proportion of A's for females is higher, tested at 99% confidence? Okay, this particular type of problem, there's a couple things that you need to recognize. First off, a 99% confidence. What is alpha? Alpha is certainly not 99%. Keep in mind that alpha is just simply 100 minus the 99, which means that alpha is not 1, it's 0.01. All right, we also need to start with the conditions. So I'm going to do the conditions on this page first. First off, we have SRS. I'm going to write conditions. SRS. Is it given or do we have to assume? Well, if I read through the 16 out of a random sample, so if it says it's a random sample, does that mean that we have to assume it's random? No, it's given. So that condition is given. Okay, let's talk about independence. Do we have a population of females greater than or equal to 270? Please do not put 160 here. Why not? Because what's our n? N is 27. Okay, so do we have a population of more than 270 females? Yes, so that should be good. Now, normality. Remember, guys, this is a proportion. The normality check is different. We're not looking for 30. We're looking for n times p to be greater than or equal to 5. And we're looking for n times q to be greater than or equal to 5. All right. So basically, 0.52, where the 0.52 come from, that's the 52% here. We're not, remember, the 16 and 27, that's our, that gives us our p hat. That's not giving us p. So 0.52 times our, times n and then we have 0.48 times 27. Okay, so 0.52 times 27 is going to give us 14. So that's definitely greater than or equal to 5. And 0.48 times 27 is going to give us 13. That's greater than or equal to 5. So we are good as far as normality goes. All right. So now it comes down to actually just doing the problem. What's the new thing that we added this chapter? Ho's and hi's. So let's start out with our HO and HI. HO. Now again, because we're dealing with proportion, we are not dealing with the mean anymore, so this is not mu anymore, this is P. And remember what the problem says. It says that I think that females do better than the general population. So that means that the proportion that we're looking at is less than or equal to 0.52. And my HI better than 0.52, so P is greater than 0.52. Now, of course, that is also my claim, so I'm going to start that with that. The hardest part about this whole unit is figuring out HO and HI, and if you're having trouble with that, please let me know. I'll see what I can do as far as meeting with you or something like that. Okay, so we have our picture. We look at HI, it's greater than, so this is a right-tailed test. Remember, we always look at HI for this. Alpha equals 0.01. And remember, it's a proportion, so what do we have? We can just go to our infinite degrees of freedom, 2.326. Should be our critical value. Again, you have to figure out your critical value. If I don't see you figuring out a critical value somehow, I can't tell you if you're right or wrong. So our z-score is equal to p hat minus p over the square root of pq times n. Okay, our p hat, that's what we observed, so that will be our 16 out of 27. Minus 0.52 all over 0.52 times 0.48 divided by 27. And if we are careful, and remember this is a proportion, so what do we have? 3 decimal places, 0.755. All right, if I have 0.755 and my critical value is 2.326 or above, are we going to reject or are we going to fail to reject? If it's not in the critical area, we fail to reject. So we're going to fail to reject. You have to write this down. You have to either write reject the null or fail to reject. And then let's follow the formula. Therefore, there's the 3 dots. We do or do not. If we reject it, we have enough evidence. If we fail to reject it, what happens? We don't have enough evidence. We do not have enough evidence. At what level? At alpha equals 0.01 to, okay, am I supporting or rejecting? Or am I rejecting or supporting? What's the next word? Well, my claim is HI. That tells me whether I support or reject. HI, I support the high. So I put support. Now, what am I supporting? We don't have enough evidence to support at alpha equals we do not have enough evidence at alpha equals 0.01 to support that females do better than the general population in math. Okay, so there you go. Again, stuff that we've done with just adding the HO and the conclusion, HO, HI, and conclusion. Very straightforward. Like I said, if you got it the first time around, then again, we're getting very repetitive. Next unit's going to be even more of this stuff. We're just going to add something else to it. So here we go. Let's take a look at the second one. I'm going to write it down and then we'll talk about it. Okay, so now we have Rolling Stone magazine doing a survey and saying that, or at least saying that 40% of college students, or not at least, it says 40% of college students drink at least once a week. Be careful here. Don't put the at least in front like I just did, because that will change the problem. It says 40% of college students drink at least once a week. All right, you surveyed 100 random students and found 37 who do. Can we reject the claim in alpha equals 0.01? All right, well, before we even get into the problem, what's the first thing we got to do? Our friends, the conditions. Okay, SRS. You surveyed 100 random students. So SRS is given. Okay, independence. Do we have a population of students greater than or equal to 1,000? Do you think there's more than 1,000 college students? I think so. And then the check for normality. Again, this is a proportion problem, so we have to do n times p greater than or equal to 5 and q times p greater than or equal to 5. So what are we doing? We have, wow, look at that, messing up already. This would be n times q. Okay, so n is 100 times p, okay, our probability is 40%, so 100 times 0.4 is indeed 40. That's greater than 5. And then we have 100 times 0.6, which is 60. That is also greater than 5. So we are in good shape as far as normality goes. We did have, we made a big enough survey. Okay, so what is HO? HO would say that P is equal to 0.40. Remember, that's 40% as a decimal. So HI, now again, we're not looking for bigger or less. We are just looking to see if we can say that that's not true. So we are looking for not equal to 0.40. Okay? So what was the claim here? Well, the claim was 40%. So we're going to put our little handy-dandy star on HO. Critical values. Okay? Based upon this right here, the not equal to, that means that I have two sides. Remember, our alpha was 0.01. So we need to find 0.005. And again, we can look at that t-table with infinite because, again, this is a proportion. We're always going to do a z-score. So that gives us 2.576 and negative 2.576. And what is our formula? Z equals p hat minus p all over the square root of p times q over n. Well, what is our p hat? Well, we had 37 out of 100. That's pretty straightforward. That's 0.37 minus 0.4 all over 0.4 times 0.6 divided by n, which happens to be 100. So that gives us negative 0.61. Now, where's negative 0.61? Is it between these two values? Yes, so it's in the non-critical area, so what do? If it's not shaded, we fail to reject. So we fail to reject the null. Therefore, we do not have enough evidence at alpha equals 0.01 to, hopefully you know, reject that 40% of college students drink at least once a week. Okay? That's it for today. That's it for the weekend. Enjoy your weekend. On Monday, I'll assign some problems to go along with this. And then, we'll go through some problems, and I'm looking at your next test probably close to the end of next week. All right, guys, enjoy your weekend.